So yesterday was kind of confusing as well. Why are you so quiet? Do you guys ever remember doing stuff in the powers previous times? Okay. So it's probably more just the details you couldn't remember. Well, let's talk about scientific notation first. Maybe you want to put this up at the top of your page, or you can go on the previous page where there's a lot of space for definitions. I'm not going to go over the definitions with you guys. I don't think that's super important. For scientific notation, the main thing you want to remember is how the answer should be written. That's pretty much the whole gist of scientific notation. Is you should have a single number times 10 to a power. Scientific notation, that's how it's written. Now, the single number could look lots of different ways. It could look like just a regular number like 5. It could be 2.36. It doesn't matter how many decimals you have. Usually people only go up to 2 decimals. But it technically doesn't matter. All that matters is that this first number is a single number times a 10 to a power. This 10 to the power part is like the placeholder. If you guys kind of remember what that is, that's like tens, hundreds, you could have tenths, like decimals. This portion at the end is just telling you what type of number it is. So these are just examples. We'll start with an easy one. You want me to go back? Do you guys need this anymore? Yeah. Okay. Do you guys remember scientific notation at all? I know you've seen it in the past, okay? If you guys use your calculator and you type in too big of a number, frequently your calculator will give you scientific notation as the answer because it can't show that many numbers. So we'll start with a really easy one, like 5,000. Scientific notation means that you're supposed to write it as a single number times whatever type of number it is. So when I look at 5,000, I immediately know the single number is going to be 5. Whatever number is at the beginning is your single number. How would I get 5,000? 5 times?
10 to the third power.
Too far. I mean, you're not wrong. 1,000. 5,000 is 5 thousands. Okay? 1,000 can be written as 10 to the third because it's got 3 zeros. 10 to the first is 1 0. 10 to the second is 2 zeros. 10 to the third is 3 zeros. This is basically just telling you how many zeros there are. That's what the scientific notation is. Okay? If I write 8 times 10 to the 9th, this is going to tell me that I'm going to have an 8 with 9 zeros. Yes? Okay. If I want to write it out, so I know it's going to be 8 billion. No. My brain's not working yet. Is that a million? Hundreds, thousands, millions, billions. Are we okay with this so far? Okay. Where it gets more complicated is when you start having more numbers. So this doesn't mean 3267 with 6 zeros. This means that you're going to have the number 3267 and it's going to be 6 places over. There are 3 blank places, so those would be the zeros. Most people like to think about this number up here as how many places you move the decimal point. It's really easy when there's no decimal point, like a 5 or an 8. But as soon as you have a decimal point, it kind of looks different. Okay. What else should we do? We should do negatives. What about 5.321 times 10 to the negative 4th? I didn't talk about the negative powers yet, huh? This is tenths, like 0.1. This is hundredths, like 0.01. This is thousandths, 0.001. The bigger the negative number, the smaller it is. So 5.321 times 10 to the 4th, rather than trying to think about how many zeros it is, I'm going to move the decimal point that many spots. So if I move my decimal point that many spots and I move it to there, I'm going to fill that in with zeros. So my answer would be 0.0005321. Your usual talkative selves. Is this making 0 sounds? You have given me 0 feedback on anything so far. Do you guys know how to do these already? So some of you do, some of you don't, some of you are just staring. Is this the I don't want to come back to school? I mean, that should have been yesterday, but. Okay, should I just start calling people here? Caleb. You gave me one of those funny looks, all right? So this is a really tiny number, right? Okay. We need to write it in scientific notation.
Okay.
What's the first normal number up there? 4. So I know my answer is going to be 4. It can only be a single number. How would I write this as a single number? 4.16. That's a single number, under 10. And now I have to figure out how many places I move the decimal. So if I make it 4.16, that means I'm putting the decimal right there. How many places do I have to move it to get to there? 2, 3, 4, 5, 6. Good. So is that right?
No.
No, Callum. No, okay, how come? You don't know. 10 to the 6th. That would be a big number.
Or you put like zeros.
Close. The negative means that it's the small number. A positive power means it's going to be a very large number. A negative power means a very small number. Why don't you pick the next person?
Oh,
You're cruel. Okay, Haley, give me some numbers.
3, 7, 5.
Good numbers. Okay, I want to write that as scientific notation. I need to start off with a single number times 10 to something. So what would be my single number?
3,
3.
7,
3.75, good. So 3 is just like the first regular number. So you're basically saying put the decimal right here. So how many spots was it moved?
4.
3, 4, good, okay.
Positive 4.
Positive 4. Good. Somebody over here, so we'll spread it out a little bit.
Mikey.
Mikey? Why did you tell her to pick Mike? Jeez. I didn't hear. Just remember that. Give me some numbers.
1, 2, 3, 4, 5.
All right, that works. I'll do this one negative. We'll make yours harder. What power should I put?
4.
Okay. So, because it's in scientific notation, I want to be able to write it in the other form. Any thoughts as how do I go about doing that?
Move the decimal to the right 4 times.
Perfect. The positive power means it's going to be a bigger number, so I'm going to move the decimal to make it a bigger number. The hardest part for everybody always is trying to figure out which way to move the decimal. And I understand why, because it's different every time. For me personally, I always just try to keep in mind whether it's a big answer or a small answer. If this was a -4, I'd move the decimal that way, and it would become a really small number. The negative does nothing to the problem. All it does is make the answer negative. It does nothing in terms of scientific notation. Okay. I don't know, there's actually nothing more to scientific notation. All scientific notation is a way of typing big or small numbers like that. To me, it's pretty useless. Okay. So, did you want me to go over this again? Yes? Sure. How about 0 powers? Was it 0 powers the hard ones, or was it mainly negatives? Okay, that's what I kind of figured. I do want to point out one typo here. This should be in parentheses, because that answer would be different if there was no parentheses. Did you guys go over the differences between that at all? Okay. So the 0 power on a whole parentheses means that this whole parentheses answer is going to be 1. Oh, what? Your packet doesn't have a negative there, does it?
No.
Oh, that's what I thought. That's why I knew there was a typo. Well, I guess we could do one of two things. You can either put a negative on the answer, or you can put a parentheses around the -32. So the 0 power only goes on whatever it's on. So 32 to the 0 power would become 1. The negative sign in front would just go on that 1. If there is a parentheses, then the number is -32, and then the 0 power would be on that. This answer would be +1. You can kind of choose whichever one is in your packet. Both of these are correct. I just knew that your packet had that typo. Okay, so in short, anything to the 0 power is 1. That's the parking restriction. Who else was gone yesterday? Okay, so I can explain to you why this answer is 1. I'm sure a lot of you don't care, but if you're curious why the answer is 1, I can show you that probably individually. I'll go right to negatives to try to save time here. One thing I didn't like about the way these answers were written is it doesn't really show why you get that answer. 2 to the negative 1 power, I'll just leave that one alone. I'm gonna guess you guys aren't good enough at powers to just like immediately know answers. 2 to the 3rd power is 8. So 2 to the negative 3rd power, if you want, you can write the steps in between. This is gonna become 1 over 2 to the 3rd. A negative power doesn't mean your answer is negative. A negative power means that it moves your problem to the other part of a fraction. Wait, I can put it right here. I write way too big for this to fit in here. Carter, can you even see anything from over there? Make sure you guys have that part written down. That's going to be the number one thing you'll need to know to do a lot of these problems. Now, if you already remember this or know this, great. Negative powers are usually the portion that most people forget. In fact, I'm not even sure if you did negative powers in pre-algebra. No? If you didn't, I understand that's why this would have been the hardest part of yesterday. Now, when I say it moves to the other half of a fraction, 2 to the negative 3rd power, it's not written as a fraction, right? So if something's not written as a fraction, that technically means it's on the top. Because you don't write over 1. You won't write something as a fraction if you don't need to. So if it's written like that, that technically means it's on the top, and you're going to move it to the bottom of the fraction. So 2 to the negative 3rd, we move it to the bottom, and it's now a positive power. And that's going to be 2 to the 3rd on the bottom. I'm kind of expecting you to use your calculator a lot if you're not good at powers. 2 cubed is 8. And that's where the 1/8 answer came from. Five to the negative 2 power. It's a negative power, which means I need to move it to the other half as a positive power. So instead of writing it as negative 2 power on top, I'm going to write it as positive 2 power on the bottom. And if nothing is on top, I just leave it as a 1. And this is 1/25.
Do we need to write it like the way they were writing it?
I don't know what that means.
We were writing it a different way.
Then what?
Are we supposed to write it as 1/6 to 2nd power or just 1/25?
Oh, the other one. Yeah, I was only writing that so that you guys knew where the answer came from. The answer that was there was 1/25. I was just trying to show you where the answer came from.
Okay, so you'll accept both?
At first, yes. Normally, if things are numbers, you guys can find answers, so you do them. If they're letters, you can't find answers. There's no letters here yet. That's why that's why it's a little bit different. Mikey, choose somebody else.
Jacob.
Can you help me do 6 to the negative 2?
Yeah, you would, put the negative 2 with the 6 under a 1.
Okay, so it would say 1 over
6 to the power of 2.
just a regular 2, good. So this would be 136. Good. Okay, another person? My bingo roller's packed up because we have our family Christmas this weekend. And I'm supposed to bring bingo for the kids. So I don't have a bingo roller.
Israel.
How do I do the next one?
You throw 1 down.
How come?
Because if you look at the example, it's 1, 3, that.
Oh, is that the example up top?
Huh?
Just, it has a 0 power.
Yeah.
Yeah. No, I didn't know if you were trying to explain the example up on top. Okay, so now we get to a little bit harder. Next person. I see you went way out of your comfort zone there. Went really far away to pick.
You put 1 over negative 5 to the second power.
Ooh, close. It's not negative 5. So if it was supposed to be negative 5, this would be in a parentheses. But since it's not, the negative 2 power is only on the 5. This negative symbol will just kind of be out front away from everything else. So the answer would be negative 1/25. But good.
Next problem.
Yes.
1 over 27.
Perfect. 1 over 3 cubed. Good. Okay. Do you guys want me to do any of the bottom 4? Does one of those bottom 4 look difficult to you?
The last one.
The last one? Sure. George, who's gonna help us with the last one? Zabi. Who's gonna stop using red pen?
I'll put down 1 over negative 27.
Okay, how come? Did you just immediately write negative 27?
Yeah, because both of these are negative.
Okay, so the negative 3 would move to the bottom, but the power is now positive 3. And then negative 3 times negative 3 times negative 3 is negative 27. If you guys remember, it doesn't matter if you put a negative symbol on the top, in the front, or on the bottom, they're all the same. So if you write 1 over negative 27, still correct. I'll just write it in the front because that's kind of how I'm used to it. Okay, good. Now we'll go to a little bit harder ones. We're gonna use the same rules, but now it's on letters and numbers. Do you want me to start to do a couple with you first before I call on people? Sure. Okay, so 4 times m to the 0. This 0 power, it's only on the m, it's not on the 4. These aren't together. If they were together, there'd be a parentheses. I don't think any of these do. So if they were together, they'd be in a parentheses. So the 0 power, I'm only going to do on the m. So this is going to be 4 times 1, which is 4. Okay, 3k to the negative 4. This is the same thing. These two aren't together because there's not a parentheses around them. So I treat them separate. The negative 4 power is only on the k. The k is going to be the only thing I move. The 3 stays on the top because it doesn't have the power on its own. And the bottom would become k to the 4th. Only the things with the negative powers are going to move. If it doesn't have a negative power on it, it stays. Okay, Zabi, can you pick somebody for me? Addie. Zabi picked you. Can you help me with this one?
Yeah.
Okay, is there anything with a negative power?
Yeah, it becomes a positive.
Okay. How do we move it? We haven't had one like this before, I just didn't know if you'd be able to do it on your own.
Yeah, it would be 7 times 4 with a positive 7, because it's being divided, so you just flip what it's doing.
Perfect. It's a negative power on the bottom, so you move it to the top as a positive power.
Yeah.
Perfect. The negative power just moves to the other half. It doesn't matter if it's top, bottom, whatever. Good, very good. Do you have somebody you want to call him?
Bailey?
Bailey. Can you help me with that one? Do you need guidance?
Well, I have an answer.
Well, then why do you sound so unsure? What's your answer?
X to the 10.
Okay,
I don't know.
that's all you got for your answer?
And then
Oh,
times 1 to the 3.
and you're just not sure if that's right?
Well, like, your dad gave us all the answers.
Oh. Well, that's definitely right. Okay, so the negative power on the bottom, that's the only thing I have to do something with. I'm gonna do something with 0 powers and negative powers. A negative power moves to the other part of the fraction. So this is gonna move to the top. And it'll become a positive power. So that's why you have D3 on the top. It doesn't matter what order you write them. If you want to put them in alphabetical order, go for it. So you guys have all these answers, but you weren't sure what to do with them?
Yep.
Okay, do you feel a little bit better about them now? Yes? Okay, I got one sort of answer. I got one answer with a yawn. You guys don't have to head nod only. You can actually like, words. Words, you're not like 3 years old or anything. We don't need baby sign language in here. And you're not that tired. I heard all of you talking as you came in. Okay, I'm gonna stop here though. That gives us about 25 minutes to work. The homework is still in Schoology. I saw a couple of people did it and turned it in, and that's fine. I put it in Schoology yesterday. There was a worksheet attached to the assignment. That's the one I want you guys to work on today.